This is for Year 12 Specialists. It comes out of 6F question 24 concerning parametric curves and first derivative and second derivative. Okay, let's do the first derivative first. It's going to be dy dt over dx dt. So dx dt will equal 2t. Dy dt is going to equal, I'll do our product rule here, t times the derivative, so 2t, t minus 3 to the power of 1, plus the derivative of t is 1, so t minus 3 squared, which will be t minus 3 times 2t plus t minus 3, which is t minus 3, 2t, 3t minus 3, which is 3t minus 3, t minus 1. Okay, so that's dy dt, that's dx dt, then dy dx equals dy dt, which is 3, t minus 3, t minus 1 all over 2t. So there's my dy dx, which is part A. Part B is the derivative of y dash, where y dash is dx dy. So the derivative of dx dy with respect to t. So y dash is 3 t minus 3 t minus 1 all over 2t. I might expand at the top, so it will give me 3t squared minus 4t minus 12t. 3 times 3 is plus 9 all over 2t. Therefore, the derivative of that, I'm going to use the quotient rule. U is the top, which is 3t squared minus 12t plus 9, and the derivative of that will be 6t minus 12, and v equals 2t, and v dash equals 2. So the second derivative, which is d squared y over d, sorry, what am I doing? Do y, sorry. This is this here. So I've got dy dash dt will equal v first, v times u dash. So 2t times 6t minus 12 minus minus 2 times 3t squared minus 12t plus 9 all over 4t squared, which will be 12t squared minus 24t minus 6t squared plus 24t minus 18 all over 4t squared. That and that add to 0. So I've got 6t squared minus 18 all over 4t squared, which is 6 outside of t squared minus 3 all over 4t squared. So I've got, this is my answer to C. I might clean up my board and see how I can do B and D. Okay, so here is my first derivative. Here is my second derivative with respect to t. Find the coordinates of the stationary points. Stationary points will be when dy dx equals 0, and that will be when t equals 3 or 1. When t equals 1, x will equal 1 squared plus 1 and 2, and y will equal 1 times 1 minus 3 squared which is negative 2 squared, which is 4. So 2 and 4 is one stationary point. And when t equals 3, x will equal 3 squared plus 1 is 10. And y will equal 3 times 3 minus 3 squared, which is 0. So 10, 0, 2, 4 are my two stationary points. If I'm looking for points of inflection, that's when the second derivative equals 0. So 0 equals 6 t squared minus 3 all over 4t squared. I can ignore the denominator, so t squared minus 3 equals 0, so t equals plus or minus the square root of 3. Let's take t equals the square root of 3 first. X will equal the root of 3 squared plus 1, which is 4. And when t equals negative root 3, x will also equal 4. And y will equal root 3 minus 3 squared, which is root 3 times 3 minus 6 root 3 plus 3, which is root 3, 6 minus 6 root 3, which is 18 minus 6 root 3. So 4 and 18 minus 6 root 3 is one point of inflection, and the other is y equals negative root 3 minus 3 squared, which is the same as negative root 3 plus 3 squared, because I can take the negative out and all squared will become positive, but the negative still adds out there. Negative root 3, 3 plus 6 root 3 plus 9, negative root 3, 12 plus 6 root 3, which gives me negative 12 root 3 minus 18. So my other point of inflection is negative root 3 and negative 12 root 3 minus 18. Just having a little look at this. If I'm squaring this, that becomes 9, which means that becomes 12, which means that's 12 root 3, and it's positive. And the 18 is because of this times this, so the 18 is negative, and that's 12 root 3, or minus 12 root 3 minus 18. So that should be minus 18 plus 12 root 3. Okay, that's done.